Hey, good day wherever you are. Today we are going to be looking at fundamental and derived quantities. In physics, there are always quantities to be measured. And today, fundamental quantities, I want to tell you what fundamental quantities means. Fundamental quantities are those quantities that are independent of any other quantity. They depend on themselves. That is, the other quantities are derived from them. For example, fundamental quantities, the three main fundamental quantities studied in physics are length, mass, and time. Then you can get other fundamental quantities like temperature, temperature, electric current, amount of substance, amount of substance. Then they are measured. The terms used to measure all these quantities are called units, and the units of fundamental quantities are those units that all our quantities depend on to be derived. So the unit of length is meter. That means length is measured in meter. There are also multiples and submultiples of this meter, centimeter, kilometer, and so on. We will look at that later. Then the unit of mass is kilogram. You can also see gram and so on. The unit of mass, the unit of time is seconds. That is, time is measured accurately in seconds. Then temperature, the unit of temperature is Kelvin. You can also see Celsius, Fahrenheit, and so on, but you have Kelvin. Then the unit of electric current is ampere. It's measured in ampere. Then the unit of amount is called the mole. You hear about that more in chemistry. Then let's go over to derived quantities. You see, let's look at area as a derived quantity. Area as a derived quantity. The unit of area is meter square, and it is derived from the combination of length. Length. Now let me define length for you. Length is can be defined as the distance extended. For example, this marker now, you can measure the length with a meter rule and you get something like 10 centimeters, 15 centimeters, and so on. So mass is the amount of matter contained by a substance. Then time is the unit or reference frame for which an event is distinguishable or measured with reference to before or after. So area, it is derived from the combination of fundamental quantities which are length times length. For example, when we have a rectangle like this, and they said you should find the area of the rectangle, you have something like 1 over 2 BH, 1 over 2 times base times the height, which is both of them are length. Or area can also be given as length times breadth or height. Just know that. Then we have volume as a derived quantity. The unit of volume is meter cube. meter cube. Volume can be derived from the combination of the fundamental quantities length. Mind you, length can be used to replace displacement. Let's say they will say that displacement is the distance reached with reference to time. So length can also be used to replace displacement, but we'll see that later when we get to dimension analysis. So volume meter cube is gotten by length times length times length, or length times breadth times height, etc. Then let's look at density. Density is in fact, apart from all these here, every other quantity you might see in physics can be regarded as a derived quantity because you need to combine any of these or another derived quantity to get it. So density is gotten by the unit of density is kilogram per meter cube. This one has a minus sign. I'll tell you why it has a negative sign. Then you see it is gotten from mass over volume. This is the formula for density. Then why does it have a negative sign here? This meter cube is the unit of volume. Kilogram is the unit of mass. But you see, for example, kg divided by m raised to power 3. We need to bring it up here because you can't give the unit as like this. But when you bring it up, it changes to a negative. So we now have, let me show you the full working. Kg divided by m3, which is kg m raised to power negative 3. This is because it was divided. If not, it wouldn't have this negative sign. If you have multiplied, this meter won't have a negative sign. I'll explain that later though. So another derived quantity, let's look at velocity. Velocity is a derived quantity. Velocity is gotten from acceleration over time. Velocity is the rate of change of displacement with time. No, the formula for velocity is displacement over time. Displacement over time. Then I told you that displacement can also be length when we go to dimension analysis. So displacement formula for the unit of velocity is given as meter per second. It has a negative sign, can you see it? Or just give us meter per second. So let's see it. Velocity is, the formula for velocity is length or displacement over time. And we now have meter over second. We need to bring it up so it now has a negative sign. I'll explain this later. This is mathematical. We'll look at that. So this is the unit. Then we have acceleration. The unit for acceleration is meter per second square. The formula for acceleration is change in velocity over time. change in velocity over time. So we now have velocity change in velocity over time, v2 minus v1 over time. So formula for the unit of this is meter per second minus meter per second meter per second. Then you divide it by seconds. So we now have meter per second. This cancels out.